Number 25 on DNS practice exam number 1. All right, so in this problem right here, they've given you a verbal sentence right here. The circumference of a circle is increasing at a rate of 0.5 meters per minute. That sounds a lot to me like a rate of change, everybody. So we were given here that the derivative of our circumference with respect to time was a 0.5 meter per minute rate there. They want to know what is the rate of change of the area of the circle when the radius is 4 meters. So the derivative that we want to know, the rate of change of the area at the time when the radius is 4. So this is a straight up related rate problem. And in a problem like this, we take the derivative that we know and the derivative that we want to know, and we'd like to ideally find one equation that relates this variable, circumference, with this variable, area. Only problem is we don't have a formula, at least not readily available or not one that we're supposed to know, that relates circumference with area. There's a missing link here. Both of those two things in a circle are a function of the circle's radius. So the one derivative here additionally, compared to these two, that we need to know is the derivative of radius with respect to time. And technically we would need to know that at the same moment in question here as the area derivative that we're looking for when the radius is 4 meters, but I don't think that ends up being really important in this problem. So here's what we're going to do. We're going to try to draw a connection between circumference and radius. Shouldn't be too hard to do. And using the derivative of circumference, which we know, we'll try to figure out the rate of change of the radius. So just kind of drew a line right here indicating that, okay, all of that was set up, and let's work on part 2 of the problem. Here's our formula that relates circumference with radius. We're going to go ahead and differentiate both sides here with respect to t. So there's the dotted line, and the derivative of circumference with respect to t is going to be 2 pi and then a dr dt. Little implicit differentiation right there. And what you'll notice here, everybody, is that we just have two unknown quantities right here. So actually the value of r at this specific moment in question doesn't end up factoring in at all. So fill in what we know. dc dt is 0.5 meters per minute, so we'll put that in right here, equals 2 pi dr dt, dividing both sides by that 2 pi, that's a 1/2 divided by 2, that's a 1/4, and that puts a pi on the bottom as well. So the rate of change of our radius with respect to time is 1/4 pi. Technically, radius is measured in meters, time is measured in minutes, so that would be the units for that. But you see then that this does not depend on a specific value of time or radius. dr dt remains constant in this problem, just like dc dt does. And now that we know this missing value right here of dr dt, now we can go ahead and try to figure out what's going on with area. So we're going to draw a connection here between area and radius, just using a equals pi r squared. We'll differentiate both sides of that equation to get dA dt is equal to a 2 pi r dr dt. And no, your eyes do not deceive you. The derivative of the formula for the area of a circle is equal to the formula for its circumference. There's probably some significance to that, but let's not worry too much about it right now. Now, in this equation right here, we're looking for the value of dA dt. We just found the value of dr dt, and we knew that the time-specific value they wanted us to deal with right here was when your radius was 4 meters. So we substitute in those two values that we know. R is 4, and dr dt is 1/4 pi. Remember, everybody, this right here is what we call a time-specific value, and it's only okay to use a time-specific value after we've differentiated, which we've done now. So solving, or really just simplifying that right side, this got really, really nice for us here. The 4 on top and the 4 on bottom canceled. The pi on top and the pi on bottom canceled, leaving us with a derivative or a rate of change of our area with respect to time of 2 square meters per minute. And that is option A.